In this video, what we are going to do is to start the software Civil 3D 2016 in my case. Sometimes you may have some kind of other software. I told you to download Civil 3D 2018. So if you have Civil 3D 2018 version, you may have a desktop shortcut in here. So I want you to double click this Civil 3D 2016 in your case, whichever the version you use, Civil 3D 2016 or Civil 3D 2018, but I want you to click on the metric version. That is the version we use for in our work. So metric version is using the units as meters. So that is the units we are using in Sri Lanka. So that is why we are using the metric version. I want you to select this Civil 3D metric version shortcut icon and double click to open the software. After some time it will be loaded. Now you can see my Civil 3D software has turned on. This is the basic interface of Civil 3D software. So depending on your version, you may see some kind of small differences in the basic interface, but more or less this interface is same. So you will be seeing that you may have something called drawing 1, and I will now explain about the interface of Civil 3D. At the top left corner you have something called application menu browser. Once you click this button, you will see there are some kind of icons appearing on the window. So these are same as Microsoft Office or Excel. So by this you can open a new drawing. By this you can open an existing drawing. Here you can do save as, and some other functions. So if you have problems with any commands, you can type here and get details of that. So that is about application menu browser. Then here you have something called workspace. When you place the cursor here, it will be highlighting what it is. So here this is the workspace. There are several workspaces. Once you click on here, you will see there are 4 workspaces here. But what we are doing is Civil 3D workspace. Then you have some quick access toolbar buttons here. Here you can create a new drawing. You can open a drawing. You can save. You can print or plot. You can do or undo and redo things like that. You see these kind of things in Word, Excel too. So I think you may be familiar with these things. Then here you have the tabs: Home tab, Insert tab, Annotate tab, Modify tab, likewise. So most of the things we do is in the Home tab of Civil 3D interface. So inside this interface you have something called panels. So this is palette panel. You can see it has a border from the others. This is palette panel. This is create ground data panel. So inside these panels you have some other options. This is point drop down. Then this is surfaces drop down, likewise. Then you have create design panel. In that create design panel you have some kind of data. Then you have profile and section view panel. So each of these panel have specific Civil 3D data. In other tabs also you have separate panels. Here you have import panel, InfraWorks 360 panel, block panel, likewise. So I move back onto my home tab. Then this one is called the tool space. This is where you have all the tools and data stored in Civil 3D. You can access all the stored data and settings in this tool space. In tool space you have 4 tabs: Prospector, Settings, Survey, and Toolbox. In Prospector tab you have all the data inside. You can view all the data within the Civil 3D drawing through here. So if you have point data, it will be showing here you have point data. So if you have alignment, it will be showing that you have alignment here. So I will show you once we go forward with the lectures. Then you have the settings tab. It has all the settings that we need to do work with Civil 3D software. Then you have the survey tab that will be useful for the surveyors, not much useful for engineers. Then you have the toolbox tab where you can use the report manager to create output reports from Civil 3D drawings. So I moved up to prospector tab where we work so much in Civil 3D. So if you couldn't find any of these tabs, you can turn it on or off through these buttons. If you click this button, your prospector would be gone. So if you click this again, your prospector will be appearing. So if you click this button, your tool space would be gone. So once you click it again, it will be appearing. So if you lose the tool space, that is how to get it back. Then you have model tab where we work. Then you have two layout tabs. So they will be used to get the output drawings, but we are not going to learn them inside this course. We are mainly working in the model space. Then you have the command bar where you type all the commands. So if you are familiar with AutoCAD, that is same as Civil 3D. So you have to type the commands here and you can do whatever the thing you want to do in Civil 3D, same as AutoCAD. For example, if you want to draw a line, you type line here in the command bar. So it will give you the line command. Once you press enter, then you can create a line like this. So this is a simple line which is a AutoCAD entity. So there is a difference between AutoCAD and Civil 3D. The major difference is Civil 3D is a more intelligent software. Civil 3D has intelligent objects. Once we go through the lectures, I will show you. It can change according to the situation once we change the parameters. But AutoCAD cannot do that. Civil 3D can do that. That is why we call Civil 3D a intelligent software. In here you have the help section. You can get help from anything you want related to Civil 3D or AutoCAD from here. Then again you can sign in if you have a when you want to log to the online account, you can sign in from here. So also you can use the online map through this function after signing in. So that is about a basic introduction about Civil 3D. Then in the next video we will learn how to set up Civil 3D interface to work with Civil 3D from here onwards. In this video, we will be starting a new drawing and synchronize the Civil 3D interface with my interface and your interface and making both our interface identical so that you will not be getting much problems while working with the Civil 3D videos. So before that, I have sent you an email regarding the data we need to use in this Civil 3D lecture series. So you may have received something like this: CE760 Civil 3D. It is a RAR file, or in other words a zip file. First you need to copy this to a place where you can easily access. I have copied mine to the desktop. Then you have to extract this using something like extract here. So you will be having this folder after extracting. Then you have to open the Civil 3D software, the metric version. If you have already done that, you don't need to open it again. You just go into the Civil 3D version. Now I am going to open a new drawing using a template. So a template means a drawing where all the standards and settings are stored to do our drawing. So in your company, if you are working in a company, they may have a Civil 3D template where you can use for your Civil 3D works. So various companies have various drawing templates to do with their Civil 3D work. So now I am going to start a new drawing with a new template. So what you have to do now is you go to the application menu browser, you click here and then go to new. Then I want you to browse to the file where I gave you, that is the CE3760 Civil 3D data folder. So that is in my desktop. I am moving here and I go into the template CE760 Civil 3D folder. So inside that you have data folder. In that data folder you have something called new road template. It is a file called new road template. So you have to open that file. So every time you start a new drawing, you have to use a new template file. You can use existing template file. Anyway, you have to use a template file. So I have opened this drawing too with the new road template file. So I will close this drawing 1. I click this plus sign and go to save changes. So there is nothing will be saved. Now my drawing 2 is opened. It is open using the new road template. Now what I am going to do is I am creating some settings, or I am making some settings so that my Civil 3D interface and your Civil 3D interface become identical. So here what I want is I want to press your shift key on your keyboard. Press your shift key on your keyboard, then right click your mouse button, right click the mouse button, shift key plus right click, then you got snap settings, click here, then you will get something like this. You then uncheck this option, snap on, uncheck this one, then snap tracking, this one also uncheck, then you move on to this snap and grid, should be unchecked, polar tracking should be unchecked, object snap you already unchecked. It is okay to have these things checked, but main thing is to uncheck these two things. In 3D object snap, make sure it is also unchecked. Dynamic input, make sure this one is okay to have, but there is another settings to be changed. I will tell you next. So after setting all those things, you click OK. Now you just type some commands. You put your mouse cursor here somewhere in the middle, then you type some commands. So if your commands are typing on the command bar, that means your dynamic inputs are turned off. So to ensure that, or to change the dynamic input mode, you have to press F12 on your keyboard. So the modern laptops, you have to find F12 key by pressing function or Fn key plus F12. So make sure that what kind of keys are to be pressed to get the F12 key on your keyboard. In my laptop, I have to press function key plus F12. So in your laptop or computer, just make sure what are the keys to type to get the F12 function. So what I am going to do is I am pressing F12 on my keyboard. So nothing will be happen, but when you type, you will see the typing is happening where the cursor is there. So if you press F12 again, you will see the typing is happening on the command bar. So I want the typing to be happen on the command bar. That means your F12 should be turned off or the dynamic inputs should be turned off. Now that is the main options what we have to be set to synchronize my screen with your screen in terms of Civil 3D. So you don't have to save the drawing in this moment, but keep the drawing open. In the next video, I will tell you how to start a project with Civil 3D for design. When you have selected the site for road design, what you do at the first, so once you have finalized the trial alignments and everything, as I told you in highway design lectures, what you do is you are going to survey that area. A surveyor will be going to that site and he or she will be surveying in that area. We call it doing a topo survey. The surveyor will get the features in that area as well as the elevations by the means of points. So the surveyor goes there and taking elevations as points, and also he is taking the objects or features in that area. So the surveyor will give us the point file where we have the elevations. Then we can use that elevations to create a Civil 3D model. The points will be used to create the Civil 3D model, what we called a surface, that is the ground surface of that area where the surveyor has surveyed. So on that ground we will be creating a new road. So I hope all of you have this drawing open by now without closing from the previous video. So this drawing is open using the new road template which I have done in the earlier video. So now what I am going to do is import points into this drawing. So to do that, you have to go to Home tab. Then you have something called points here. You click this drop down. You go to point creation tools. Then small bar will be appearing. You can drag it here. Then you click this button, import points button. Then another small window will be appearing, that is import points window. Then here you can select the files. You click this plus sign. Then you go to your desktop. In my case, that is my desktop where the data are saved. So I go to CE760 folder and go to data folder and make sure your file type is CSV, this type CSV. Then you will see inside this data folder, inside this Civil 3D data folder, topo survey points. You click this point, click this Excel file, this kind of Excel file, and click open. So In Sri Lanka, the surveyors are usually doing the surveying with a file format called PNEZD. That means point number for P. N means northing, E means easting, PNEZ means the elevation, D means the description. So you have to specify the point file format. So you have to go down here. You will see PNEZD, comma delimited option. Then you have to select that one. Then you will see I am dragging here to enlarge the window. So you will see the point numbers, northing, easting, point elevation and description in these points. So these are the points in this drawing. Even though you have small number of points here, it is only a preview. So you have so many points inside this file. So if the file is successfully imported, you will see a green check mark here. Then you have to put a check here, add points to point group. Then you click this to give a name for the point group we are importing. We say topo survey points. Then we click OK. So we will uncheck this option, uncheck the both of these options, and we click OK. So your point file will be imported to your Civil 3D, but you will not see anything at the first place because you cannot. It is imported to a location where we can't see in this screen. First, I will close this toolbar. Then I will double click my mouse wheel. You should have a mouse with a mouse wheel to do Civil 3D or AutoCAD work. Otherwise, it is very hard to work with Civil 3D or AutoCAD based softwares. So definitely you should have a mouse with a mouse wheel. So what you have to do is you have to double click the mouse wheel, the middle button. You have to double click the mouse wheel. Then you will see the points are appearing inside this drawing. If we zoom in here, you can see the point detail. This is the point number, this is the elevation, and this is the description. TE means tar edge, the existing edge of a road. So if we come here, this is the center line of a road. Likewise, you have so many points. You have some kind of this might be a boundary wall. So these descriptions, survey point descriptions, will be given to you by the surveyor. Here you have touch points. This is telephone post. Likewise, you have so many points which are taken by the surveyor. So we have imported the points into our drawing. Now we are going to save this drawing with a name. To do that, I am clicking save here, save option here. Otherwise, you can go to application menu browser and click save. Then I am going to my desktop and go into this file, and not in the data folder, outside the data folder I will save my drawing as points imported. Then I click save. So up to this point we have imported Civil 3D points into the Civil 3D drawing. In the next video we will be discussing something called external reference. So we will be looking at that in the next video. Please don't close the drawing, so you can work with this drawing in the next video also. In this video, we are talking about a concept called externally referenced drawing. In the previous video, we have imported civil 3D points into our drawing where a surveyor has been taken the surveyed points and we have imported that points into our drawing, but we still don't know whether these points are imported to the correct location. There's no clue for us whether we have imported the points to the correct location. So to ensure that, we are doing something called externally referenced drawing. So we are going to do that now. First, I am going to save this drawing as a separate file. To do that, I go here, application menu, browser, then you go to save as, then you type the file name as external reference, then click save. Now what I am going to do is I am going to externally reference the drawing into this current drawing. To do that, I am typing xref in my command bar. Place the cursor in your command bar, then type xref, xref, and press enter. So you will be getting a small window like this. You can drag here and click here, this small drop down, click attach drawing. Then you go to desktop. In my case it is desktop, and you have to go to the Civil 3D data folder which I gave you. Then you click on this data folder here. Then click on this topo survey drawing. Click on this topo survey drawing and click open. So another small window will be appearing. Make sure this scale button is unchecked. This insertion point is unchecked. All these points are unchecked, and make sure the drawing units are meters. Then click OK. Then you will see there is a survey drawing appeared in our points drawing. It is an external drawing. It is not in this drawing. It is an external drawing. So we are creating an external reference, like we are looking something from a butter sheet. So we are something like that. So this is at the background, not inside this drawing, not on top of this drawing. It is inside the background. You will see the survey. So that is what you call externally referencing a survey. So if we have done something wrong in our point import option, that means if we have imported the points to a wrong location, so this survey and the points will not be coincide with each other. That is how you make sure that your points are imported to the current location. So if your both survey and points are at wrong locations, we can't help for that one. But if they are at the correct locations, but we have done it in the wrong, if we have done it in the wrong way, we can make sure that we have done something wrong by externally referencing a drawing. If we have done something wrong, this external reference drawing will not be coincide with this drawing. So I will close this external reference manager. Then you will see the points are these star edge points. That means the edge of the road points are connecting through a line. Then you have the we have some other lines also. Here you have another road going outside. Likewise there you have building edges. So that is how to externally reference a drawing. So if you don't need to see this drawing, you can unload it. So to unload it, you type xref again in your command bar and you go here or press only xref and then press enter. So to avoid to hide this survey, you have to unload this one. Right click and unload. If you want to reload it again, you can reload it. Unload and reload. Likewise, if you want to remove this drawing from this attachment from this drawing, you have to click this detach button. But I am not going to do it. So instead I can do unload for a moment if I need. Otherwise you can keep it with you by reloading the drawing. So that is how you create an external reference to a working drawing. So in the next video we are going to create a ground data model or ground model from the imported points. In this video what we are going to do is we are going to create a surface or the ground data model from the points we have imported. Before that I will change this drawing name as create surface. To do that I go to application menu browser, then go to save as and I change my name as create surface and then I click save. So it seems like my external reference is making a little bit of a problem here, so I will hide this one. To do that I type xref in my command bar, press enter, then I click this propose away button drawing and right click unload. Then I close this external reference manager. Then what I do is I go to prospector, then here surfaces. Make sure you are going in the prospector tab, then surfaces, right click, then create surface, and your type would be thin surface, then the name would be existing ground. Let us say EG existing ground. You can say the description as existing ground. So this surface will be displayed as with a contour style of contours 2 meter and 10 meter background. You can change them later. For the moment I click OK. So still we have created a name for the surface. We haven't added any data to this surface. To do that, you go to prospector again and surfaces. You will see that now it is populated with the name called EG, but there is no data here. In my first videos I told you that whenever the data is available it is showing in the prospector. In my drawing we have civil 3D points, so it is giving me a bullet sign here. It's giving me a notice that we have points here. So these points are shown in this preview area. So if you drag it somewhere up, you can see the point number northing easting will be shown to you. So that is happening when you have points. But here we have only the surface name. You don't have any data here, so it will not showing in the preview area. So in this, what we are going to do is we are going to we are going to add data to our surface. To do that, I go here, expand the surface, then you have EG, I expand it again, then you have definition, we expand that again, then you have something called point groups. You right click there and go to add. Then you have 2 point groups where you have, that is all points and topo survey points. Both are same, but you have to select the topo survey points, that is the point group we have imported in few minutes earlier. So I select topo survey points and click OK. You will be seeing that the surface is appearing on your drawing. So this is the surface, these are the contours, this is the ground data surface. So I will, if you got a message like this, you just click here to turn off that one. Then you click somewhere in this gray output or this green line and right click, go to object viewer, then you can maximize this one using here. Just drag the mouse, you will see some kind of a 3D model in this area. So you can change the type from here. So then you will see the things very clearly. You will be seeing now there is some kind of a road going on the middle. You can see it here, some kind of a road going in the middle. And I will close this for the moment. And you can see the surface, this green area is the surface border. So you can see the point details are in this area, but the surface is also appearing in this area. So there is something problem is there. So without point detail you can't have a surface, but just connecting these points from this point to this point, it is creating a surface. But at the middle of this area we don't know what are the things are there, so we can't say this in this area the surface is correct. It should be going like this where you have the points. So you have to correct this one. To correct this you need to apply a boundary to this surface, so that we are telling the surface you have to go within the boundary we give it to you. So that boundary would be the edge of the points in our drawing. So to get the boundary, I want you to go to the drawings folder. That means you have to go to here this application in your browser. Then this time you go open and go into your Civil 3D data folder. Then you have something called boundary. Then click open. So you will see a boundary like this, a polyline like this, that is a boundary. So what you have to do is to select this one, then right click, go to clipboard, then select this one, copy with base point. Then it is asking a base point in the command line. Type in the command line 0, 0, 0 and press enter. So it will be copied into your drawing, into your clipboard actually. Then you move on to the create surface drawing. Create surface drawing where we have the surface. Then right click, go to clipboard, then go to paste. So it will be asking paste specify insertion point. So click there and type 0, 0, 0 where you type for base point similar as that one. Then press enter. Then you will see some kind of a boundary is appearing in the drawing. So even though we copied a boundary, it is not appeared, it is not applied into this drawing yet. So we have to apply it. Now to apply this, what we have to do is you go here, surfaces, then you go to EG, expand it, then you go to definition, then you go to boundaries, right click and go to add. Then write your name as outer, then uncheck, don't change these options, click OK. Then it will be asking in the command line, select a object. So that is asking to select a boundary. Now zoom into your drawing and select this yellow colored boundary we copied earlier. This yellow colored boundary we copied earlier and click it. So you will see your boundary is shrinking into your drawing, shrinking into your new boundary. Your old boundary is shrinking into your old new boundary, so that you give the drawing a new realistic view without the unrealistic edge initially posed in this location. So that is about creating a surface. In the next video, we will be talking about applying break lines and exporting and exporting the surface to a LandXML version. In this video, what we are going to do is something called adding break lines to a surface. So that is something important when you are doing a civil 3D work. When you are creating a civil 3D surface, especially, you have to add break lines. Break lines are something called items where you know when the surface changes at a definite point. So I will show you that. To do that, we have to change this drawing name as add break lines. So I go here and click save as and change the name as add break lines. Add break lines, click save. Then again I am going here and going to open a new drawing. So in your data folder, you have tar edge and centerline lines. That drawing, click that one and click open. So you will see something called, you will see the tar edges and centerline of the road, existing road in the drawing we are working with. So it is extracted to a separate place in here. So it is giving only these lines in this drawing, but you see here it is showing these lines, these center lines. We are marked as a line, so it is giving those lines in a separate drawing. So what we are going to do is we are copying this line into that drawing. So to do that, select all the objects, right click, clipboard, copy with base point, then 0, 0 will be your base point. Click enter, then go back to your add break lines drawing, this drawing, right click, clipboard, paste, then you type 0, 0, 0, 0, 0, 0 as your insertion point. Press enter, you will see the lines are coming into this drawing. So what we are going to do here is, we know that within the tar edge lines and center line, that means within the existing road, the road have a definite shape, because a road have a definite slope and definite shape within the road edges and the center line. It is different from the existing ground. It has a definite shapes when it comes to the road. So if you think of a dam, it has a definite shape. So where the slope of an object is, where the slope of an object can be identified without any problem, we call that line as a break line. So you can identify the edge of the lane and center of the lane easily. So we call them as break lines. In terms of a dam, top of the dam will be a break line because you can see at the top the slopes are changing from that dam edge line. So that is how to identify break lines. If you consider of a channel or an irrigation canal, you will see the bottom of the canal, the slope changes, and at the top of the canal also slope changes. So those lines would be break lines. So here we have the road edges as our break lines. So we will be applying them into the surface to get a more accurate surface. So to make sure that we are getting a more accurate surface, I want you to click this one of these contour lines. So you will be getting whole surface selected. So you will have to be seeing something like this, thin surface EG. So if you don't see something like this, press escape button on your keyboard. Then again select this line. Then you will see this. Then right click and go to Object Viewer. So once you just click this, drag this mouse somewhere here, you will see some kind of a road is going on the middle. Even though it is going, you can see the road is not smooth. Even though you can see a road, the road is not smooth. That is what we see at the moment. When I press close here to close that one, then I select these three lines. That means this red line, this light blue line, and the pink color line. Only these three lines and all things will be selected. Then I go to Prospector, Surfaces, EG, and then Definition. As we go earlier, we click Break Lines, then go to Add. As the name, we type Break Lines, and your type would be Proximity, and you click OK while they are selected. There will be a small error, but you have to ignore that. It's a minor problem. Then what I do is I click this contour line, one of the contour lines. So you will be having something like this. Then again I right click and go to Object Viewer. Then I again see my drawing. Now you will see a more clear road in the middle. In the initial option, your road is something not like a rough surface, not like a road surface. It is something like a rough surface. Now, even though the outside of the road looking rough, but the center of the road looking more smooth now. That is because of the option we gave by a break line. So that is the importance of break lines in Civil 3D. I close the Object Viewer in the previous step. So you will be having this kind of drawing now. So now you know what is the importance of break lines. In the next video we will see how to export our surface into LandXML. So far we have imported points and create a surface. After that we added a surface boundary, then we added break lines to the surface and make the surface more realistic. And so far we have done with the surface. We have completed everything with the surface. But when you are working with the surface, if you see all these point data and break lines in your drawing, it will be a burden to work forward from that drawing, because you will see all these things inside the drawing and you can't properly work. So in that case, what we are doing is we are exporting this surface, something called LandXML or some other version, and make the surface more user friendly so that we can work without much of a trouble of the data inside the surface. So first part, we are going to export this surface into a LandXML version. That is kind of a LandXML is kind of a file type which we use globally to transfer data. So this drawing file would be the drawing file which contains the surface would be transferred to a file type called LandXML, where other Civil 3D users can use the surface without seeing these point details and break lines and boundaries, all those things. In the LandXML version, what you have is the final surface only. It will not have the point data and all that. So that is kind of, if you remember a slab of a building, when you are building the slab, you have all the formworks and all the jacks and all these other things we are using to form this slab, but after forming the slab we will be removing all those things. So by LandXML also we are doing that kind of thing. We are removing all the unwanted parts of the surface and we are retaining only the needed parts inside the surface to work with the surface more easy and convenient manner. So to export the surface into a LandXML version, you go here for prospector surfaces, then you go to EG where your surface lies, you right click here, then go to export LandXML. After that you will be seeing a check mark here, surface and EG, then click OK, then you can go to the existing folder outside, then to type the name as EG because your existing ground surface is there and your file type will be LandXML. Then click save. So your surface would be now exported as a LandXML surface. So far what we have done is importing points, create the surface, add the boundaries for the surface, add break lines to surface, and finally we exported the surface. So now we are going to close everything, and from the next point onwards we are importing the exported LandXML surface. That means we took the surface out of the drawing. Then in the next video we will take it into the drawing. Actually it will be into a new drawing, not this current drawing. So after exporting this, I want you all to close this drawing by saving it. In the last video, we knew how to export the surface to a LandXML version. In that, we created the surface from points and we added boundaries and then we added break lines and finally we exported that surface which has all those boundaries, point data and break lines to a file version called LandXML. in this video we will learn how to import that into another drawing. So to do that, I want you to open AutoCAD Civil 3D, whatever the version you have. However, you have to open the metric version. Then what you have to do is you have to open a new template from the template I have given to you. So here I go application menu, browser, then go new. Then I am in my desktop where I have the data folder. I select new row template and click open. So a new drawing with new row template will be opened. I will save this drawing as Import LandXML surface. So to do that, I go here, then save as. I'm going to my Civil 3D folder, then I save it as Import LandXML surface, then click save. So only we have saved the surface. We don't have any data in here because we opened a blank drawing template. So since my drawing name says that Import LandXML surface, I have to import the surface into this drawing. Import means we are getting something from another source. So that source is a LandXML surface. So to do that, I am going to this Insert tab here in the ribbon Insert tab. Then you have LandXML. Depending on your version, it may be different, but the view may be different, but you may find in the Insert tab LandXML. I click here. Then I go to my desktop where I save that LandXML file called EG. Then I select it, then click open. So you can see a small window appears. You don't have to do anything to this. Just click OK. Now our surface will be appeared in this drawing. You can see the break lines are appeared in white, so that you can get an idea where the break lines are. But they are not necessary to this surface. So you can delete these break lines. To delete them, you just click them and delete. Press delete on your keyboard. You will see now those lines are disappeared. These lines are actually contours. You can't delete them. So once you select these lines, you will see it appears as thin surface EG. That means it is selecting the surface. So currently the surface is viewed on contour. You can change the view of the surface. Before changing the view of the surface, you can see my surface is still selected. I press escape to deselect the surface, so it will not be selected anymore. So you can see now there is only a surface. You don't see any boundaries as we applied earlier, or you don't see any point data here. So this is a more simplified surface. You can't. Initial surface was a kind of complex surface because you have all the way, you have the point data and you can't see them clearly. You can't see the surface clearly. You have point data all the way. So this surface is kind of a less complicated, a simple surface which would help you to work with very easily than the previous surface. So that is why we are using the LandXML conversion to create less weight or lightweight surfaces. Now I am going to change the style of the surface. To do that, I click here, then right click on my mouse button, then I go to surface properties. Then I go to information tab here, information tab. So I can change the style here, surface style. Currently it is contour 2 meter and 10 meter. So you can change it to contour 1 meter and 5 meter. Then you click apply, you will see the changes here. So you can use other design types and apply and see how they work. So this elevation banding means elevations, the surface is colored according to the elevation. So the slope banding is elevation, so the surface is colored according to the surface slopes, likewise. So for the moment I will keep this style as border only, so that we will see only the border of the surface. So now you will see only border of your surface. So that is how you import a surface to LandXML. In the next video we will look at how to create an alignment inside this surface to create a new road to our project. In this video what we are going to do is we are creating the background to generate or create an alignment within this surface. So before that I have to tell you we are still on the Import LandXML drawing. So we imported the surface and we set the surface style to border only, but we haven't saved the drawing. So I will save the drawing from here, or otherwise you can do it from here. Initially we used save as option. Now since we are in this drawing, we will use the save option. You can use this option, or else you can use this option, save. So I will use it here, save.